finally it's the last week of the semester. Next week is the final exam. So final exam is on Monday. It's at 10 o'clock, 10:45. Yeah. So please check the final exam. So if I received the email from the registrar office, there are several conflict schedules due to the mistake of the registrar office. But as far as I know, there's no problem on our schedule. So, but to make sure, just check with the other class for the final exam. Then contact the instructor to resolve any issue on the final exam. Final exam will cover the chapter 8 through the end of the last chapter, chapter 13. Then the format will be the same as the midterm exam, but it's paper based. So I think that we may not have enough seat. 1, 2, 3, 4, 5, 6, 7. The 1, 2, 3, 4, 5 is a 1070. So those who are late will take the exam. One, okay. So we have the 1073. I think the one student cannot take the final exam 72. So 2 students will take the exam in the front. It's up to you. If you are late, so you will take the exam in front. So otherwise, we will each student will take the one seat. Okay, the 70. Okay. So then, any question regarding to the final exam? Okay, so as I announced before, please check any mistake or anything problem on the grading on Canvas, so with the GA or me, before you take the final exam. After the final exam, you can check only the final exam sheet. Then right after checking the exam sheet, the final grade will be reported to the registrar office, because I'm going to be out of town from the Friday the next week, so I will not be available after that. So before that, we need to take care of everything regarding to your final grade. Okay, any questions? So today we are going to talk about the last chapter of the semester, which deals with the virtual memory. Okay. So anyway, the name implies it's not real memory, it's a virtual memory. So so far we have talked about the operating system. So operating system, as we discussed a lot, is a software. It's not hardware, but definitely you need to understand the computer architecture, as well as the user need, which means it's a software part and the user interface. So we are going to implement the program that deal with the hardware and the user, the need. That will be the kind of interface between the computer and the users. Okay, so by considering a lot of the algorithm that we have discussed, so it's a part of the software. But the main problem of the operating system is to deal with very limited resources. Okay, due to such a lack of the resource, there are a lot of things we need to consider. If we have unlimited resource, we don't have to worry about too many such an algorithm. Just assign, and that's it. We don't have to do the CPU scheduling. So if you have unlimited the resource, and there are something we need to consider, like the synchronization problem. We cannot avoid it, even though we have enough resource. But most of the time, since we have the very limited resource, we need to coordinate. That is the main purpose of the operating system. Specifically, the memory is one of the devices that affect the performance of your system. Because the memory, what is the characteristic of the memory? RAM. Actually, we need this one to speed up, to access the data, because when CPU access the data in the persistent disk, so it takes a long time. Because of that, we try to keep some medium, in between the storage, that is a RAM. RAM usually faster than the persistent disk, but problem is it's usually very limited. Not only just the price, but also it's affected by the processing, the addressing. and then so on. So we usually have the very limited resource of the memory, which means so we need to take care. We need to manage such a limited resource. So last time we talked about how to use the memory. Simply we can allocate the huge chunk of the what? The program. So eventually we try to create the process. So as we spend a lot of time, so we spend half of the semester to create how to create, what is the process, how to create the process, how to manage the process. So actually the process is everything on the operating system. Okay. So then where is it? It's in the memory. So we define the process as program loaded in the memory, right? So which means if you double click or if you create if you run the program, it will create the process, which means so your code will be loaded into the memory. At that time, we follow the certain rule, data structure, process structure, like the data, global area, the heap, and the stack, and so on. Okay? If we have enough space of the memory, we can just load into the memory. Old the version of the operating system like the MS-DOS or mainframe uses such an approach because it's simple and it has only the process we need in the operating system. However, nowadays we have more and more processes. So like how many, have you ever checked the laptop? So Windows 10 usually concurrently, how many processors are running? 50, 100, more than 100 processors are running. Some of them are small. This is sometimes from time to time it's active, but some of the process need 200, 300 megabyte memory size, and sometimes it's a thread. Because of thread, it will be huge. So mostly, most of users complain that we do not have enough space of the memory. That's nature. Okay. So we try to address that problem, instead of the big chunk of the memory space for each process, we divide into the segment. Segment is the meaningful chunk of the process, like the main program or subroutine or the library. So we can assign such a segment by segment. Still, it calls the external fragmentation, which means even though we have enough space. Oh, by the way, what if you do not have enough space on the memory? The only way, we need to take out the current process and make the free space and load the current process, which is called the swap in and out. So we need to do the swap in and out, but nowadays, as we discussed, we don't use the swap in and out swap processing because it takes a long time. Okay, so it calls but sometimes even though we have enough free space, but because it's a segment, it's divided, we cannot load the current process. So which is called the external fragmentation. So external fragmentation is another issue. Also, we have the internal fragmentation. It's a relatively small, the loss of the memory space, but it may affect. Our goal of the memory management is we try to maximize the utilization. So to address those problems, last time in chapter 8 we talked about paging. So paging is instead of the big chunk of the program and the memory, we are going to consider the fixed size of the unit for both physical memory, which is called page frame, and logical memory, which is your program on your hard disk drive. So we consider the program on your hard disk drive will be loaded into the memory. So why don't we consider such a your program as the logical memory? That logical memory will be loaded into the physical memory. At that time, we divide both physical memory and logical memory by the same size. So instead of moving in and out by the big chunk of the program, we are going to in and out such a fixed size of the unit, which is called the page. Okay, so it's a page by page. For the in terms of management of such a paging, it's the same idea as the other, the memory protection and the memory. Like we can consider the mapping table, segment by segment. No, it's a page by page. So since we have the number of pages and the number of page frames, sometimes it takes time to mapping and manage such a page. To address that problem, we can consider the TRB, so which is the loop aside buffer. So even we can keep the cache of such a mapping table. Okay, then we can speed up. Also, there are several approaches. Like what if we have the huge number of the list of the page frame? Then at that time we can consider indexing. So there are different the approaches for the management, the hierarchical and the hash, and also we can consider inverted the management of such a number of pages. That's what we discussed the last time. So it's a page. By the way, I'm not sure whether I mentioned what is the typical size of the pages. I/O block size in the operating system is a 512 bytes. But what about the memory page size? It's mostly power of 2, but it's larger than the block I/O size. So which means the 512 bytes. Some of the operating system use the 512 bytes, and nowadays the bigger size of the page, because our memory size and transfer the data amount are the bigger and bigger. So we nowadays use the bigger size of the pages, like the 2K or 4K. So some of the operating system support the dual size of the page, like the 512 byte, also as well as the 2K or 4K page size. Now it's a kind of trend to use the bigger size of the pages. Okay, so today here we do not have even though we use the page, that doesn't mean we can have the bigger size of the physical memory. Our physical size, our size of the physical memory is still the same, just like the CPU scheduling. Even though you have the perfect CPU scheduling algorithm, we cannot increase the CPU time. The only thing we can do is maximize the utilization of the CPU time. Even sometimes 100% is not recommended. It's mostly the infinity loop. Okay, so it's a waste of your CPU time. So memory, even though we are using the big chunk contiguous approach or the segment approach, page approach, we cannot increase the physical size of the memory, which means it's limited by the page frames, okay, our physical memory. So, but we have the more and more process to be loaded and to be running the same time. So, which means it's the multitasking is limited, and the degree of your programming will be less and less. So, to address that problem, the operating system nowadays, most of them are using the virtual memory. So today we are going to talk about the virtual memory. As name implies, it's not the real memory, it's a virtual memory. So idea of the virtual memory is the last time we considered this is our computer and the CPU, and we have the memory. So this is the page frame. So we have a number of the page frame. Then on the hard disk drive, we have the program. So if this is called the logical memory. So if we have the logical memory and divide by the same size of this is called the pages, and also this is called the page. Then we can have the mapping table, MMU. This is the logical memory, the page number, and the page frame number. Then we can find it. Okay. However, we can have another process. It's another logical memory, so it can be loaded into the memory. So like this one. However, that doesn't mean that we can increase the number of the process the size of the physical frame. So to address that problem, idea of the virtual memory is, why don't we consider this one is the anyway the memory structure. Okay, so we divide into the same size as the page, the unit. Then this one we consider all the logical memory is in the memory. But actually practically, even though we are running for example, MS Word, which require, for example, 200 megabyte the size of the memory, okay? Do you use all the functionality of the Microsoft Word? First time, even though you will not use all the functionality at the same time. Okay, you will start from the main and the sum of the file open and the sum of them. So when we create the process, so this logical memory, so this will be loaded into the physical memory page frame, but this is a physical memory. We consider extension of the memory, which is actually in the hard disk drive. So this is a hard disk drive, and their data structure is the same as the memory, which means pages. So it has the number divided by the page, like the 512 byte, 512 byte. So when you create the process, so we need the 0, 1, 2. So 0, 1, 2 is mapped to the 2, 4, 6. 2, 4, 6. Then the other 3, 4 are loaded into the memory, but in the virtual memory, which is the extension of the physical memory, but it's in the hard disk drive, the mostly persistent disk. Okay, then if needed, so for example in the pages 6, it called this one 3, and this one is in the virtual memory, so we load it into the memory at that time on demand. So for example this one is the 3, so it's loaded into the 3, then finally access. Okay, then the other process is the same thing. So when we create the process at the same time, so allocate the physical memory as needed. Then the others will be loaded into this one. Then whenever it needs, it will be loaded. So benefit, we can virtually extend the size of the memory. So which means degree of the programming will be higher. So we can support the multitasking. And another benefit, that's the benefit. The problem. Then the problem. What if this one is the full? We do not have. So we need to actually in and out. Just like the swap in and out. Swap in and out is for contiguous approach or segment based. Entire chunk will be the swap out, then the new chunk, new process will be swapped in. Similarly, in case that all the pages are full, so you cannot find the pages, so you need to load the new page, but there is no free pages. So this is called the trap. At that time, we need to find. So similar as the swap in and out, we need to find the victim page. So let's say this one is not used or something reason that we will take out, which means go back to the virtual memory space. This is called the page out. Then bring the new one in the free space paging. So we need to do the page in and out. Benefit, it's not like the entire chunk, it's not entire segment, it's just a page in and out. Another small benefit is, so we don't have to worry about the two process, where is the is processed like the disk I/O. Need the disk I/O, but the other disk, when you read the data from the hard disk drive, the other latency, we do not just consider this one as the extension of the memory. So using the same addressing format, we can get the data. Physical I/O overhead, we cannot avoid, but the processing time will be, latency will be slightly reduced. So this is called the page in and out. So we need to do the page in and out. So we will see the first in this chapter. We will see the what is the virtual memory. So I already explained, but the physical improvement. So we are going to. This is called the memory page replacement. Replacement. The problem is what will be which page will be the victim page. Then, like you can think about always first in, first out. Okay, which is the simplest and usually works. But it's not always. For example, this one is this page is loaded, but this is the system. Okay, used for the kernel. So you cannot move out the page out. So you need to consider least recently used. Which one is the least recently used? If not used a lot, then it will be victim. So we will see several algorithm how to decide the victim page. Okay. And there's another benefit of using the paging approach for virtual memory, based on the pages. Another benefit is, for example, both of the process are using the standard I/O library, system library. This one is the standard I/O. So this one is already load the standard I/O, the page. Then we don't have to load this one again. Instead, we can just share. Okay. So we talk about this one, the last chapter. So you can actually share the shared library using this virtual memory paging approach. So we will see a little bit more details here. So the idea of the virtual memory is a separation of the user logical memory is a program from the physical memory, which means we will consider this additional extension of the memory. Where is it, by the way? It's a hard disk. Somebody confused. This is a virtual memory, so it's like the memory, but due to the limitation of the physical memory, we will extend this one. Mostly it's a hard disk drive. What about the Windows 10? Does the Windows 10 use the virtual memory? It is true. Nowadays, the capacity, size of the physical memory is bigger and bigger. Sometimes you don't feel any need of such an extension of the memory. So if you are using your laptop only for the browsing, okay, browser of the internet. But most of the students in this classroom probably need the bigger size memory. But what about the Windows? Windows 10 also use the virtual memory. So how can you, have you ever checked your virtual memory on the Windows 10? So if you go to the system property, okay, you can see the advanced setting tab. Then go to the first one. You can read. I'm not sure whether you can read. It cannot be bigger. There is a performance, a visual effect, blah blah blah, and the last one is a virtual memory. So if you click, so you can actually change the size of the virtual memory. So here, so right now it's setting as 1 GB. Okay, so if you want, you can change the size of that, and small size and the maximum size and so on. It was recommended to set up the virtual memory size as 2 times of the physical memory. So if the physical memory size is 1 GB memory RAM, then the virtual memory is 2 GB. Even though you set up the 10 GB, 100 GB, you cannot get the full benefit because anyway, when you access the page in the virtual memory, it requires physical I/O. Okay, it doesn't have a lot. But even nowadays, if you read a document or manual of the Windows, they do not suggest to increase the bigger than the 1 GB. This is the default because our physical memory size is nowadays pretty much big enough. So in case the intensive job, you need the virtual memory. Also, it can be automatically extended based on the need. Okay. What about the Linux or the Unix system? It uses, so most, as I said, most of the system, they use such a virtual memory. For example, I'm going to open this is the CentOS, the virtual memory, and the operating system. So if there's a command, it's a general command, general purpose command, free. So if you type the free, it's the information, it shows display the information about your memory. So this is the memory, physical memory is for this virtual machine is 300, 400 megabyte, and this one is used, this is physically free. Then you can see the swap. Nowadays you can see the swap, the name of swap in the operating system. However, this swap is not the same concept as the one you know. The swap is the entire. The process will be swapped out, then the new program will be loaded into the memory. That's the swap in and out. However, nowadays we use the name of swap, but that is not for the real swap. It's used for virtual memory. So on Linux or the Unix, if you need to change or the manage or set up the swap, that doesn't mean the real swap space is for the virtual memory space. So this is the virtual memory space. Right now it's set up as the 400 and used is very rarely used so far. The others are free. Okay. So if you see the name of a swap in your operating system nowadays, it means the virtual memory size. So you can monitor. So think about you are the administrator of your operating system. So your system is slow. There are a lot of things you can check. Okay? So why your system is slow? The first thing you need to do is this virtual memory. If there is a lot of I/O or use a lot of the virtual memory, which means your physical memory is not big enough or something problem on your replacement algorithm, your page replacement, which is called the thrashing. We will see such cases later, but this is the one thing you can check. Or if you go to the swap, PROC, yes, swap. So for example, swap. So you can see if you do not know where is the swap space, virtual memory space on the Linux or Unix system, you can check the /proc/ the swap file. This file has the definition, the location of the virtual space. In this case, the file name is the dv/sda file, which means that this one is as the name implies, it's a hard disk drive, the persistent disk. Then it's a separate partition is used, and the use is the 668, as you can see here. Okay, and the total size is here. So you can check that this file to see this. I will explain I will show the couple of more commands later on how to monitor your virtual memory. Okay. So this is the virtual memory. So virtual memory is the separation of the program, logical memory. Whenever you see the logical memory means your program, your process. Then from what? The physical memory, which means that we are going to use the hard disk drive as an extension of the physical memory, the memory. Then problem is anyway, so we need to in and out because it's limited. That's called the page in and out. So, but the problem is how to decide the victim page that determine how to replace the pages. There are several algorithms that we are going to discuss today and the last class. Okay, so such using the virtual memory provide several benefits as we discussed. So then the efficient process creation, it can be the high degree of the programming. And problem is how to implement. I already answered that. So we can use the page that we define the last class. So we can use the page by page, the in and out for the implementation of the the virtual memory. So, and this is the benefit, pros and cons of using the virtual memory. The problem and the solution of the virtual memory. So right nowadays, most of the operating system use the virtual memory approach for the memory management issues. So this slide shows the schematic diagram of using the virtual memory. You can see at this time this is your process, logical memory. So which means that we consider this is the virtual memory. So but we do not load all the pages to the physical memory page frame. Instead, some of them are needed. Sometimes it's called on-demand, the demand page or demand segmentation, in case we are using the segment. So it's a demand page. Then what about the others? The others will be loaded into the secondary storage, which is mostly the hard disk drive, file system, but separate the file system, which is called virtual memory space. Sometimes it's called the swap space. So if you see the swap space, so that means it's a virtual memory space. Like that, later it will be in and out problem. So this is another the diagram that I found from another textbook that clearly shows what is the virtual memory. So this is a disk storage, but this will be to consider the virtual memory will physically divide into two. Virtually, this is one, like the disk, but physically it's separated. That is the idea of the virtual memory. I have seen based on my experience, so many of the students a little bit confused. What is really virtual memory? Okay, so virtual memory means it's the data structure to consider our program as it's a virtual memory. Then instead of loading entire pages of your program, separate. Then some of them will be in the page frame. The others will be loaded into the. What if we have enough space of the physical memory? Then we don't use a lot, as we have seen on my virtual machine. Okay. Also, another reason of using virtual memory is if you remind the data structure of the process, like this is the very high level of the data structure of the process. It's a process structure from whole data heap and the step.